Okay, this is a document. It's for the prison mathematics project. It's a document full of a lot of questions that are, I'm going to say, at the high school level. They don't go beyond, for the most part, they don't go beyond algebra, some simple geometry, pre-calculus. There is some calculus questions over here, but certainly not a lot. All right, but if you notice over here, there's a lot. I mean, a lot of material over here. The document's 362 pages long, and there's a lot of questions, all right? But what I do is I kind of divide it. What I do is divide it into parts, all right? So I got this over here. Oh, by the way, before I do that, I do want to point out, if you're looking at this document over here, it says, a brief introductory video is available. And I'm sure people that, if they're watching this thing and then may not be in my classroom, but they still see this on YouTube, they may want to reach out to me. That's a possibility. So what I'll do is I'm going to put my name down. My name is Ron Bannon. And again, if you need to reach out to me, my email address is Bannon. That's B as in boy, the @ symbol, NN, ON .us. All right? So again, my name is Ron Bannon. And my email address is B as in boy, the @ symbol, NNON.us. So this is a document. This document is being shared with the Prison Mathematics Project. All right. Now in the document, there are embedded videos. So there's a brief introductory video available for students and faculty using the document. And there's another brief video regarding Sage Math as it relates to this document. All right. So what I want to do is I'm going to just pick a problem at random, and this is set 1, and set number 1, I'm going to pick number 5. But what I'm going to claim over here, if you have access to the document, my encouragement is this over here: do all the questions, and it should take you roughly 60 minutes to complete all 5 questions. Now, what I mean by that, if you can't answer them, you skip them. I mean, you answer what you can in 60 minutes. But if I would say a well-prepared student that doesn't get stuck, by the way, everyone gets stuck, should be able to complete 5 questions in 60 minutes. All right? They're not difficult questions, but the bottom line is, like a lot of questions, although they may not be difficult, you may find them difficult. All right? It happens to me too. A simple question sometimes causes me a great deal of pain. All right? What I want to do is I want to concentrate on problem number 5. All right? So, what I would recommend you do if you are watching this video, pause the video, read the question, see if you come up with an answer to it. All right? Now, what I'm going to do is, I'm encouraging you to pause it, do the question. And by the way, these are typical questions that I just, either a student has given to me at some point or I saw it somewhere. It's typical. It really is. But yeah, I'll read it to you. And certainly you should read that to yourself. And you see a picture over here. Make sure you understand it. All right, so pause the tape and then come back a little bit later. All right, I'm going to move forward though. I'm pretending you've actually paused the tape, by the way. And I'm going to scroll to that part of the question. You notice I put answers down for you. And I'm going to kind of talk through the answers. And as I do that over here, I'm hoping that you had a similar response. And what I mean by that, you looked at my answer, looked at your answer, and agreed with it. Our work may be different. And furthermore, you might look at my work and say, well, I don't like your work. It's not very good work. Well, what I'm going to do, I'll go back and read to you. It says, 2 large right triangles are identical. So I see those 2 large right triangles, and they said they're identical. So what does that mean? They both have the same base. I'll write that down for you. So I don't know what the base is. I'll just simply say the base is the same in each case. So the base is the same in each case. Well, let me back up a little bit in that. So the base over here, they're both the same. They're both of the same base. And their heights are the same. And I'm going to call the height of it A. This is A. And this height over here is also A. All right? So they say 2 right triangles are identical. It says the internal triangles are similar to the larger triangles. Well, if they're similar, they're just scaled. That's all they are. So the pink triangle, pink, like if I did the pink triangle, what's its base would be? Its base would be B over 3. And what's its height going to be? A over 3. Now, the blue ones, again, I'm not saying I'm drawing a great picture of these are the blue ones. Well, the blue ones, the base would be, there's 4. So it's b over 4. And its height would be a over 4. Let's say 2 right triangles are identical. All the internal triangles are similar to the larger triangles. They're just scaled, by the way. Which is larger, the pink area on the left or the blue area on the right? Well, I got to start counting. And there's going to be 1, 2, 3, 4, 5, 6. There's 6 of those pink triangles. What's the area of the pink triangle? 1/2 times the base. Well, the base is b over 3 times the height, which is a over 3. Well, let's see if I can do that. And this is the area. I'm doing the area now. And what do you get there? I guess you get AB over 3. All right, let me just check that out. Yeah, 6 cancels. Yeah, AB over 3. All right, let's do the blue, and I'm going to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them. And what's the area there of that? The blue triangle would be 1/2 times the base. The base is b over 4 times the height, which is a over 4. Well, I got to look at it. I'm going to say 5AB, right, by over 16, right? You know what? I'm looking at the two, and I'm wondering which one's bigger, but they're different types of fractions. So what I have to do is I got to give them the same denominator. So this guy over here, well, the common area between 3 and 16 is 48. And what times 3 would be 48? 16, so it's 16AB. And this guy over here, if I want to make it 48, what's going to be? Well, 3 times 16 is 48, and 3 times 5 is 15, so 15AB. Well, clearly looking at it, which one's bigger? The pink. Again, if you just look at 16 and this one's 15, the pink is larger than the blue. Let's take a look. And again, we're seeing the answer over there, and we're seeing the work. Now, granted, someone may look at my work and say, well, I don't think your work is what I did, but I got the same answer. Well, you really have to explain yourself, all right? No matter what you're doing, you got to explain yourself. So if this is a competitive exam, it's not enough to say this. You'd have to justify that. You couldn't just simply say that. You have to justify it. And this is one clear justification of why the pink area is bigger than the blue one. All right, I hope this has been helpful. But again, let me repeat this. This document is being made available to the Prison Mathematics Project. Let me outline that for you again. That's right over here. Prison Mathematics Project. If you need to reach out to me, my name is Ron Bannon, and my email address is this over here. Now, granted, the document's long. I just did one of the questions of the first 5 questions that I presented. Again, thank you so much for paying attention.